Hi all, and welcome to my presentation on arrays in Java. Let's get started. So what is an array? Well, an array is a data structure that represents a list of related values. Some examples of this would be voltages, a grocery list, a list of baby names, etc. So when we talk about arrays in Java and in computer science in general, there's several different terminologies we use. First off, we have the index of each element. For example, if you have a list of baby names as we showed previously, this would be element 0 with an index of 0. This would be element with an index of 1, element with an index of 2, element with an index of 3. That starts at 0 just because that's the way it works. And we also say this array has a length of 4 because it has 4 elements, and we also assign it a name. Just call it baby names or whatever. So when we create arrays in Java, there are several different ways we can do this. First off, we can declare an array. Just creates an array called baby names, so without assigning anything to it, doesn't allocate anything for it. We can also initialize an empty array that pre-allocates memory for that array. In this case, we're allocating an array called baby names to a new array of strings with 4 strings in it. And we can also assign actual values to it. This is an array literal. Essentially, you're just putting values separated by commas between curly braces. And you don't have, it's already pre-initialized. So a little bit more in depth into how to declare and initialize stuff. So whenever you declare an array, it's just like declaring any other variable. You have the type. This will be the type in the entire array. You can't have different types in an array. It must be all the same type. And then you can have the name, and then just add a pair of square brackets after that. And then when you do a initialization to an empty array, you just say new, whatever the type is, and then number of values you want in the array that's going to be empty. And then this is going to generate an array object. You can put any other array object in here, for example, an existing array or a array literal, etc., etc. So how do we actually get values out of an array? Well, we can treat this, we can treat an array just like a normal variable by putting a pair of square brackets with the index we want to access after that. So if we wanted to access our element with index 2, we can just put a 2 in here, and we can assign it values and get values just like a normal variable. So in memory, Java arrays are represented as a reference to a list of references that actually point to the actual data in memory. So in this case, we have an array called int data. Data is just a 4-byte address which references this list, and each element in this list represents the actual data that it goes to. One example that I wanted to show was just a simple sum of array. So all we're doing here is we're iterating through our array, and we're accessing the array element I, because we iterated I throughout the array, to our running total, and we just print out the running total, and that calculates the sum of an array. And I'm just calculating the sum of this, and if you run it, you can see the sum of this array is 45. Another example I wanted to show was a array of objects and how we do that. So in this case, I created an array of objects as such. I have the data type as cat, and then I just put a pair of square brackets. It works perfectly fine. And I initialized this to an empty array of cats. And then I assigned each element in the array a cat. And then I iterated through the array and printed out cats. And as you can see, this works. So essentially, when you're creating an array of objects, you interact with it just the same as you would with any other array variable, object variable, except it's an array of objects. So just make sure you access the specific index you want to get out of the array, and you can treat that just like a normal object. In real life, we often need to represent values in more than one dimension, and in Java we can represent this using multi-dimensional arrays. In this case, I've taken this matrice and converted it into a simple 2-dimensional array of integers. All you have to do to declare a multi-dimensional array is put multiple pairs of square brackets after the actual initial declaration. And this is a 2-dimensional array, so we have 2 pairs. If you want it 3-dimensional, you put 3, and so on and so forth. And essentially all you're doing is you're putting arrays into an array. I have an example down here which demonstrates it. You create 3 arrays, and you put them into another array. This creates a 2-dimensional array. So how do we actually interact with these things? Well, because the way we made it, where we have an array of arrays, the first, just like typical array accessing, the first value accesses the value, or just gets which array we want to get from. So if we didn't have the 0 here, we would just be returning an array value. For example, in this case, we would be returning this array with an index of 2 or 7, 8, 9. And then we can also address which element we want inside that array that we just addressed, which is element 0, so this points to 7. And we can do the same thing over here where we have row 1, so this, row 1, which is going to take us here, and column 2, which is going to be 6. So a lot of times we'll use arrays as a method parameter and return it from a method as well. So in this case, all you have to do is if you want to return a value, you say int, and then however many dimensions you have of square brackets, and then the same thing for parameters, just like this. So here's a quick little example on how to pass methods, arrays into methods and return them. So I create a blur function over here, and what this does is accepts an array value, which is a two-dimensional array, and returns a two-dimensional array back. And this applies a 3x3 discrete Gaussian blur of a sigma value of 1 in convolutions to each element except for the ones on the edges because I'm lazy. And yeah, so this accepts this in and we return it just like that. It's pretty simple stuff on how to use this for methods. Then we have another one over here. This is a display. This displays a two-dimensional array and it gives it commas and new lines, so we'll make sure it's actually readable. And then we just print out the output. So it accepts a two-dimensional array called array, and then it operates on it, converts it to a string, and then prints out the output. So let's see what happens when I run it. So what this does is this just takes the middle elements that aren't touching the edge, and it just flattens them out a little bit. So this is a little bit more flat when compared to the ones next to it. In Java, we sometimes use a concept called variable arity to pass a variable number of arguments to a method. In this case, we can implement this by just putting ellipses after the variable type we want to put into the argument, and we call it as such. So it can accept any number of arguments, assuming, of course, they're the correct type. And just one thing to note, you can have multiple arguments in here. You could have an int I before string args, but the variable of variable arity, or the variable with the ellipses, must be the last variable, the last parameter that's passed into the method. So when and why should we use arrays? Well, one common use is collections of data of the same type. For example, a list of groceries, collection of cats, the alphabet or possible states, which might be a static array, which we don't change. We also use arrays a lot for mathematical operations. This is pretty much collections of data. For example, we use these for neural networks when we operate with gradients, and of course we use them with kernels as we demonstrated in the Gaussian blur example. And we also use them for variable arity, as we just showed. So thank you for listening to my presentation. Here are some sources that I used for this presentation, and have a nice day. Bye.